Today, we're going to dive into a choice that is absolutely critical for anyone building in a really unforgiving environment. I mean, think about the Gulf Coast, or any place where you've got extreme humidity, constant heavy rain, and high winds just hammering your home. In those conditions, a material failing isn't just some small problem, it's a full-blown disaster waiting to happen. So what we're going to do is a head-to-head showdown between two building sheathing materials, the old industry standard OSB and a really impressive modern challenger, MgO.
So let's just ask the big question right up front. What does it actually take to build a home that can stand up to everything nature decides to throw at it? In a coastal environment, you're not just building a house. You're basically building a fortress against a climate that is trying to tear it down. You're fighting intense humidity, corrosive salt in the air, you got termites, you got mold. Everything is trying to break your home down from day one. And the choice of your sheathing? That is at the very heart of this entire. Okay, so let's meet our two contenders. In one corner, we have OSB, that's oriented strand board. It's the industry standard you see everywhere, and it's an organic, wood-based material. In the other corner, magnesium oxide board, or MgO. This stuff is a cementitious, inorganic material. Now, at first glance, that seems like a pretty simple difference, right? Organic versus inorganic. But that one difference, well, that's the whole key. It explains literally everything about why one of these is built for survival and the other is, frankly, compromised from the get-go. So let's jump right into the first round, water. And we're not just talking about a big storm or a leaky roof here. In a lot of climates, we are talking about months and months of 90% humidity just soaking into your walls. Water intrusion and water retention is the #1 cause of building failures, which makes it the absolute most critical test for any material. And this, right here, is the critical failure point for OSB. Because it's wood-based, it's just incredibly vulnerable to moisture. It basically acts like a giant sponge, soaking up water not just from leaks, but right out of the humid air around it. And this absorption, it kicks off a catastrophic chain reaction inside the panel. And this chart just illustrates it perfectly. When OSB gets saturated, it can swell up by as much as 10% of its thickness. Just think about that for a second. Your walls are physically getting thicker. This swelling permanently pulls apart the wood strands. It just breaks those internal bonds. Now look at the contrast with MgO. It's inorganic, it's hydrophobic, so it has exceptional dimensional stability. It swells by a tiny 0.1%. That means it doesn't warp and it keeps all of its structural strength. So here's the most important part. Once that swelling happens in OSB, it's a one-way street. It's totally irreversible. The panel's ability to hold a screw or a nail is just gone. The pull-out strength is destroyed. As the source material puts it, just bluntly, when it gets saturated, it's scrap. You have to replace it. So the very thing holding your house together gets weaker at the exact moment you need it to be the strongest. Okay, so let's move on and see how this weakness plays out at the next level of threat. We're talking acute disasters and biological attacks. This is high winds from hurricanes and that constant assault from mold and termites that just thrive in these warm, moist climates. So during a hurricane, that structurally compromised, wet OSB loses its ability to resist the huge forces that are pulling on the building. The seams between the panels, they become massive failure points, creating a weak line where the wind can just peel the siding right off the house. MgO, on the other hand, stays completely rigid. Its stability and density basically turn the building's exterior into a non-yielding shield, designed to withstand flying debris, like in the classic 2x4 test at hurricane speed. All right, now for the invisible threats. This quote from our source material just frames the issue perfectly. The ultimate survival question for a material: are you a food source or are you inert? If you're building in a warm, moist place, your walls are basically a giant buffet for mold and pests. And yeah, this scorecard pretty much says it all. OSB, since it's just compressed wood, is literally the primary food source for mold and mildew. Once it gets damp, that mold can spread like wildfire deep into its core. But MgO is 100% inorganic. It's minerals, not cellulose. There is simply nothing there for microorganisms to eat. The exact same logic applies to insects, like the incredibly destructive Formosan termite. They go straight for wood fiber. MgO, on the other hand, is like dense concrete to them. It can't be eaten, it can't be burrowed into. You're just taking their food source completely off the table. Okay, so let's say a house survives the storm and the pests, but then there's an electrical fire. The difference in performance here is, honestly, it's a life-or-death situation. Let's look at the ultimate fire test. The performance gap is just enormous. It's not even a fair fight. MgO is classified as non-combustible,
It gets a Class A fire rating, which is the highest you can possibly get. That means zero flame spread and zero smoke spread. And the really important part is, it gets that rating just because of what it's made of, its mineral composition. No chemical fire retardants needed. OSB? Well, it's wood. It burns fast, it produces a ton of heavy toxic smoke, and it has to have chemicals added to it just to meet the minimum fire code. And this isn't just theory, by the way. There's a really powerful real-world example of this. During some absolutely devastating Canadian wildfires, a structure built with MgO panels was reportedly the only one left standing after the fire just ripped through, consuming everything around it. It demonstrated total structural integrity and non-combustibility under catastrophic heat. Amazing. Okay, so let's move beyond those immediate threats and take the long-term view. I mean, you expect a building to perform for decades, right? So how do these materials stack up when it comes to long-term durability and, their impact on the planet? So let's start with just raw strength. When you look at sheer performance, MgO typically gives you about 40% higher compressive strength compared to a standard OSB panel of the same thickness. It's just a stronger, more rigid material right from the start. But strength isn't just about day one. What's really interesting is the long-term degradation of OSB. The adhesive bonds holding all those wood strands together, that's its Achilles heel. The constant humidity cycles stress those chemical bonds, causing them to break down over time. And that leads to fungal decay and delamination, basically a slow structural death. So that initial cost saving you might get with OSB, it often gets completely wiped out by really expensive repairs down the line. So we've established MgO is stronger, it's more durable. But this is where the story takes a really surprising turn. What if I told you a building panel could actually help fight climate change? And here it is, the jaw-dropping fact. MgO isn't just carbon neutral in its production. As the panels cure over time, they actively absorb carbon dioxide right out of the atmosphere. The panel literally functions as a carbon sink while it's just sitting there as part of your home. Now, the science behind this is a process called carbonation. So the magnesium oxide in the panel chemically reacts with CO2 in the air, and it converts it into stable magnesium carbonate. What's so cool is that this process not only locks up carbon, but it actually makes the panels stronger over time. And the benefits just keep coming. MgO has a low-emission manufacturing process. It's non-toxic, no VOCs, no asbestos, no silica, which is absolutely huge for your indoor air quality. And because it helps you build a super tight, high-performance home, it can create a thermal envelope that can radically reduce your energy costs. We're talking by 50% or even more every year. And look, if you're thinking this all sounds like some unproven, newfangled technology, it's actually the exact opposite. MgO-based cement has an incredible track record. Ancient Roman builders and the engineers of the Great Wall of China used this stuff for its amazing stability. This material has a known history of holding up for millennia. So the takeaway here is pretty clear. In a hostile climate, MgO solves the critical failure points of OSB, just across the board. And that brings us to our final thought. Given that the safety of your biggest investment, your home, relies on materials that have to withstand fire, water, and insects, what other legacy building materials that we all rely on maybe need a second look as we try to plan for a truly durable future?